What's up, guys? It's your boy Justin, back at it again with another YouTube video. Today we're going to be talking about some projectile motion. Got our problem right here. Luke throws Drew out the window with initial speed of 21 meters per second at an angle of 38 degrees to the horizontal. You need to calculate the horizontal distance traveled by Drew if he leaves Luke's grasp at a height of 1.9 meters above the ground. Okay, since we're given the degrees, the initial speed, we can find the initial velocity of x and y. First, Vix equals 21 up here times the cosine of our degree, which is 38. Then same thing for VIY, 21, except it's the sine, 38 degrees. Alright, plug these into your calculator. 21 cosine 38 equals 16.548 meters per second. 21 sine of 38 equals 12.929 meters per second. Okay, now that we have those, we can set up our x and y charts, find what we are missing. Vix goes over here, 16.548 meters per second. You know the acceleration of x is always 0 meters per second squared. And then we do not know the change in x yet. Gonna leave that a question mark. Go over to the y side, see if we can find all three. Got the delta y up here, 1.9 meters. Our acceleration of y is always negative 9.8 meters per second squared. It's due to gravity. And we found our VIY up here. It's 12.929 meters per second. Okay, so now we have all three on the y side. We can plug that into our equation, which is delta y equals initial velocity of y times time plus 1/2 acceleration of y times t squared. So we have all these, we just need to solve for time so we can plug it into the x equation. Sorry about that. So 1.9 equals 12.929 t plus 1/2 negative 9.8 times t squared. Multiply values together. 1.9 equals 12.929 t, or be minus because it's negative 9.8 minus 4.9 t squared. Need to subtract the 1.9 over, put the negative 4.9 t squared in front, plus 12.929 t minus 1.9 equals 0. Then use the quadratic formula. A equals negative 4.9, B equals 12.929, C equals negative 1.9. Plug that in. You find that T is equal to 2.482 seconds. So now that we got the time, we can plug the time back into the other equation, get our delta x. Just draw a little line here, keep it nice and organized. Write the equation again, delta x equals vi of x this time, times time. Sound a lot there. Plus 1/2 a of x times squared. Plug in our values. We don't know the delta x, but I know everything else. VIX is 16.548 times 2.482 plus 1/2 acceleration of x at 0 times our time again, time squared actually, 2.482 squared. Can multiply these two and these three, but since there's a 0 over here, all the stuff on the right side will cancel out, so you just need to do 16.548 times 2.482. Do that. 16.548 times 2.482 should give us our answer, which is 41.072 meters. So yeah, that's how far friend Drew here is thrown. Hopefully he's okay, but I guess we'll never know. If that's the answer to our problem, that's it. We're done. Alright, what's up guys? Justin again, back with another YouTube video / part 2 to our first YouTube video. Today, I'm going to be talking about some relative motion. So let's get right into it. Problem we have: boys hop on a motorboat, try and cross shark-infested waters. The boat's speed in still water is 5.8 meters per second, but it must aim at an angle of 30 degrees with respect to a line perpendicular to the shore in order to cross the shark-infested waters in a straight line. 3 questions you need to answer. What is the speed of the current? What is the resultant speed of the boat with respect to the shore? If the river is 450 meters long, how long would it take for the boat to cross? So for part A, pretty simple. We're given the 5.8 meters per second speed of the boat, and the angle that it must launch at in order to go straight is 30 degrees. You can use some simple trigonometry. This theta here is equal to 30 degrees. So our sine 30 equal to the opposite over the hypotenuse. So it equals the velocity of the current over our 5.8 meters per second. Solve for the velocity of the current. You multiply the 5.8 over. Sine of 30 times 5.8 is equal to 2.9 meters per second. So that's how fast the current is traveling this way. 2.9 meters per second. Pretty simple. Part B, very similar, except now instead of finding the velocity of the current, we're finding the velocity of the boat with respect to the shore. So we can use our same 2 givens, the 5.8 and the 30 degrees right here, except this time we need to use cosine because cosine is equal to adjacent over the hypotenuse. So the cosine 30 equals velocity of the boat with respect to the shore over at 5.8 meters per second, which is the speed of the boat in still water. Plug that into your calculator. You get, let's see, velocity of the boat with respect to the shore is equal to 5.023 meters per second. There we go. Then finally, part C. Since we now know the speed of the boat with respect to the shore, which is the straight line going here, we can see how long it would really take. Use some division. So the 450 goes on top. Needs to travel 450 meters. It's going 5.023 meters per second. Those meters cancel out. Just do 450 divided by 5.023 equals 89.6 1.588 seconds to cross the shark-infested river. Ooh, good luck. Gotta be quicker than that. Escape these sharks. But yeah, guys, other than that, that's pretty much it. Relative motion. Justin signing off.